Okay, my second video in a very short time. You didn't have to wait long for the second video in a very short time, that's what I was trying to say. But this was mainly why I did the update on the Give a Slice project, so I can publish this video, which I think is quite fantastic, at least for me. I'm trying to prove to myself that free energy is available, or is around us, or is that we are able to source free energy. And today I did try a circuit which I got from, well, what's his name? Richard Ritter in German. And I'm just trying to prove to myself that it's working, or if it's not working, I want to find out that it's not working. So what the circuit mainly does is it's using a battery to charge another battery, and traditionally if you charge a battery with a battery, you can never put more in the battery you are charging than you can get out of the battery, which is the battery providing the power to charge. So with this circuit, everything is supposed to be different. According to Richard, it's I guess it's about 1 to 8, meaning if you have one battery, let's say you have one of those batteries, you should be able to charge 8 of those batteries with just one battery. Well, I cannot confirm this at this time that you can use one battery and charge 8 batteries, but what I sure can confirm so far is that yes, I'm charging more into my empty batteries than I'm withdrawing out of my charged battery. And I'm trying to show you the circuit and how I did this. Got to get the camera off of the tripod, just a second. I'm going to show you the circuit first right now, and then we go from there. Okay, there's a little mess because I didn't really prepare on or plan on making this video, but I was just so fascinated that at least I got some free energy here that I have to publish this. This actually is the circuit of Richard Ritter. It looks like it's a mess, but actually he made it kind of simple. Just match the colors to the color. You have a coil with 2 separate windings. One winding with a thicker wire and one winding with a thinner wire. Actually at this time I don't have a circuit diagram, and I'm currently lacking the information how many windings are on this coil, but I'm trying to get this information again. This circuit I just got from Richard. I did not build this myself, so I don't have the circuit, and he didn't have a circuit. He just said, you know, take my whole circuit, or he didn't have a drawing of the circuit. He just said, take the whole circuit if you wish and test and see what you can find out. So what Richard did is he used a 9-volt battery to power the circuit and charge the battery. I did try this too, but I also did use, instead of the 9-volt battery, I did use one of those to power the circuit, and another 2 to charge with the circuit. As I said, I'm trying to get some more information on this circuit at some time, or maybe somebody else has drawn a circuit plan, because this is not closed source. This circuit is, at least in Germany, distributed through different channels, or has been distributed through different channels, so that people can try and see what they get. So we have the battery leads, positive, negative, go into the side, and from here you can basically see where it goes. One goes to the green connector, the other one goes over here to the light, to the switch. This video is not meant to explain how to build the circuit on your own, even if I wish you would, because I just don't have circuit drawings. I just want to show you how it's working. So here we got a diode. This basically is the bottom from the transistor. This is the switch, and this is the light bulb, and this is just the large resistor, 27R. Don't even know what this means. I didn't even try to measure it if it's 27 ohms only, but then it must be high wattage. But this is all information which can be found out. The interesting thing is, while the circuit is working, this light bulb is also light illuminated, and that's let's see if we can get this on camera. That's 12 volts, 0.1 amp, so this means 12 volts and 1 watt. So the magic of the circuit basically seems to be in this coil here, because in the coil on the inside there's a strong magnet. It's one of these super strong magnets. It's a round ball. Let's see if I can open this up. No, I'm not going to open this up right now, but yes, I will open this up right now. Let's see. No, you know what? I got another coil here. It should be more easy to open it up. That's actually a similar coil. I guess he used a different gauge of wire, but the same amount of windings. If I find the amount of windings he used, I'm going to put this in the video description. But anyway, the magic seems to start in here. I'm trying to get this open. Just a sec, I've got to get the screwdriver or something. There it is. Oh, come on. There it is. It's just a round strong magnet which is in here, and while the circuit is powered, is spinning real fast. You can kind of see this stuff here on my finger. You know, there's no bearing, so this actually is plastic. The coil, this is plastic, some kind of PVC or so, which was just material, and he machined it to make it to give it this shape. So we can see if I can fire this up. I did use this battery to see how much charge I can get in one of those. I'm going to give you the results in a little bit. Actually, that's a very small battery. That's only 4 amp hours, 4.2, but it's showing what it's. You can use it to show what you want to show, or you can see if you can get the results you're expecting. So I'm just going to connect this battery here real quick. And then turn on the power. No power. Oh, you know, you should pay attention. That's actually the rectifier, and the leads I did connect to the battery are the leads which are supposed to go on the battery, which is getting charged. So shame on me for making such a mess here. I need these two leads which feed the circuit. Yeah, I'm always smiling about those people saying it's kind of difficult to shoot a video while you need the other hand to do something, if you want to show something, but I just realized it's really difficult. So I'm going to put the camera down and hook up this battery. Okay, you see the light is... Can you see this with the camera? Let's turn on, let's turn it off. The light is very dim. And actually the magnet is not spinning as of right now. But the battery, this battery is kind of empty. I don't want to use this right now for demonstration purpose, because I want to have fully charged battery for something else later on. So I'm trying to see if I can get it running with this battery. Nope. Let's put the camera down once again. What I'm doing here is, you need to make sure this north and south alignment on this ball inside the coil is at the right position, and I'm always not sure where it needs to be, so I'm just playing around till it starts spinning. It almost started spinning. No. Well, I cannot get it to spin right now, probably because the power in the battery is too low. But I just want to show you the circuit. Sure, one day you'll find more information. Let's get to what I found out about the circuit, which I think is of more importance right now, because I don't even have the drawings for you to rebuild this as of right now. So what I did, I got myself 4 of those batteries here, 4 amp hours lead acid batteries, traditional, brand new. And then I got this Arduino Uno board, got a few voltage dividers, and got a relay board. So what I'm basically doing with the Arduino is I'm going to draw power from the battery while I'm maintaining the voltage on the battery, and then I'm seeing how long could I draw power from the battery until the voltage was too low, meaning the battery was empty. So in my case, after some research, I decided the battery is empty if it's reaching 11.9 volts without being deep discharged. And this is what I'm doing right now. You see we are having 12.02 to 12. We are drawing power right now, and this is actually my test setup. I got this little halogen light bulb here that's 12 volts, 5 watts. Doesn't really make a difference what the power is to get what I'm doing here, but I want to draw as little power as possible because these batteries, on those it even tells 4.2 amp hours, and then it shows 20 hours. This means the 4 amp hours should be discharged within a period of 20 hours. This means only 0.2 amp hours an hour, and 0.2 would be whatever, 3 watts or so, 2 watts, and I'm drawing 5 watts because that's the smallest bulb I had on hand. So I'm withdrawing power from one of those batteries at pretty much twice the amount they suggest you should, because it won't last as long, as it will discharge faster, but basically still is showing what it's supposed to show. So what I did first, I had these 4 batteries, I did charge them all up, and I just did connect them to the circuit and see how long they last. And the longest I had the battery last after my digital charger. Oh, that's something else. Let's see. Where is it here? The longest I ever had the battery run while it was charged was 192 minutes. So this is my reference time, 192 minutes with a fully charged battery to power this light bulb, until the Arduino board is only reading 11.9 volts and turning off the circuit. Actually the code I said if it's smaller than 11.9, so it needs to be 11.89 I guess, to turn the battery off. But that's pretty much what I did. So I did use the 4 batteries, got the maximum time a battery would last with the light bulb. And then in my test setup, let me show this to you real quick. I did connect one fully charged battery to my low voltage device, and on the output, instead of the light bulb, I did connect Ritter's circuit to charge 2 batteries. So I used 1 battery to charge 2 batteries, and then I did test the current which was drawn from a Ritter circuit, which was almost 1.5 amps, depending on when I put the amp meter on here. Actually I'm using the X tag. So almost 1.5 amps withdrawing, power withdrawing from this battery, which is way too much for a 4 amp hour battery. That's why it didn't last too long, but it didn't really matter after all, because it's only important how much am I withdrawing from this battery, how much am I putting into these 2 batteries, and on the bottom line, do I gain any power? So let me show you what happened the very first time I did this. Well, this is in German because, you know, that's my native language, but I'm trying to see, I'm going to give you a screenshot here so you can see what I did. That's still a draft here, but it's kind of showing what I did. So 5 watts, what does it say? It drew 1.5 amps. Yeah, here it is. It was kind of disappointing when my low voltage device stopped it charging after only 820 seconds. Actually 821 seconds. 821 divided by 60. After less than 14 minutes it stopped charging these two batteries. And I thought, man, this battery cannot be empty yet, but it just 1.5 amps was just too much power withdrawn. So what I did after the circuit turned off, charging the other two batteries through Richard's circuit, I just did connect the battery once again to the light bulb, fired it up and waited how long it would take to discharge the battery, which was not fully charged anymore. And to my surprise, it took 155 minutes, while a fully charged battery never took more than 192. So this gave me a difference of 37 minutes. I actually used 37 minutes of lightning power. Oh, what's going on here? I used 37 minutes of lightning power to charge these two batteries. So now the question is, out of the two batteries, will I get out more than 37 minutes? And yes, I did. I just discharged these two batteries the same way I did discharge the other ones. Hooked up the first battery first. I got about 37 minutes of light out of the first battery, 2240 seconds. And I got 46 minutes of light out of the second battery, which was exactly 2807 seconds. And this gave me a sure plus of 46 minutes light. So this was pretty amazing, because that's more than 1 to 2. And remember, while Richard's circuit is working, there's even this little light bulb making some light. But I'm not taking this into consideration, because I'm just interested in what do I really get out of what I have to use. So it's more than 1.2. So right now you see the light is illuminated, because in the second run I did the very same thing. The two batteries, which were originally charged and then discharged using this light to give me these 2 times here, 37 and 46 minutes, have been charged once again with Richard's circuit. And for a total of only 651 seconds, which is roughly 10 minutes, almost 11 minutes, and then the circuit would shut off. So no problem. I did use the battery, which did drive the circuit, did hook up the light again and try to see how long will it run, and it did run the light for 175 minutes, while the max I got out of fully charged was 192. That's why I got 192 minus 175 is 17 minutes. So I actually did use 17 minutes from the fully charged battery to drive Richard's circuit, because I had 175 less left to power this light bulb. So 17 minutes, and I did charge 2 batteries, so this means I should get 8.5 minutes of light out of each battery. So what you see here right now is discharging the charged batteries again using my low voltage protector circuit. We are at 11.97, won't take too long and it'll turn this light off. That's the second battery. So 8.5 minutes. Let's use the calculator real quick. What's going on? 8.5 times 60, 300. So if there would not be any power gain, there should be 300 seconds of light out of one single battery. So the first battery so far, I got out, instead of 300, 1500 seconds. About 5 times as much as it should have been, at least, to be coming out even. And now the second battery is still discharging. You see, the first one had 12.3 volts, stopped at 11.9, took 1553 seconds. So the second battery is still discharging since 1259 seconds at 11.97 volts. So we'll see how long it'll take, but you already can see 1200 and 11.9. I assume it will be about the same as the 1500 here. So this would be just roughly 1500 times 2 is 3000 divided by, oh here, 3000 divided by 60, 50 minutes. Why I did only use or lose 17 minutes of lightning powered driving Ritter circuit to charge the batteries, which now provide me with roughly 50 minutes of light. Isn't this amazing? I mean, I believe there's free energy devices out there, and I know people will challenge me on that it's not working, and the room temperature has something to do with the batteries and how long they will give you a certain amount of power and all this stuff. But that's actually the third test run I did, and I'm quite of satisfied, and I guess I did prove at least to myself that free energy is for real. Sure enough, the little batteries in this little circuit and the little magnet ball which is turning into this in this coil here, that's not practical for daily use yet, but who knows what Richard is coming up with in the future. At least that's a nice first step. So finally, as my last conclusion or my last information I want to give you is, I did try the very same thing using one of those batteries, empty ones, to be charged with Ritter circuit, and as the charging battery I did use a 9 volts battery, an alkaline 9 volt battery. So according to Wikipedia, the 9 volt battery alkaline has a max of 600 milliamps, and if my calculations are not totally off, that means a 5 watt light bulb, which would be 0.56 amps at 9 volts, can be illuminated on this battery for a maximum of 1.07 hours. So this means if I use this little 9 volt battery to charge this battery, I should not be able to get more than 1 hour of light at 5 watts out of this battery. So let's take a look. Oh, actually I didn't put this in here yet, but I got it on here. So with the 9 volt battery, charging the 4 amp battery, and then discharge it to 11.9, as I always do. I did start charging it at 15:06, which is 3 p.m. through 15:25, which is 19 minutes. And I did measure the power, and it was a brand new battery. Power dropped quite a bit, quite fast, down only to 5.27 volts, or lowest actually was 5.14, but this was right after I did make a little mistake and did shortcut, or make a short on the battery for about 2 seconds. So sure enough, this didn't do the battery too good, and I lost quite some power and I guess power potential out of the battery. But still, the battery worked for 19 minutes, so I did charge the 12 volt battery for 19 minutes, and the 9 volt battery is not totally drained. It just couldn't maintain the magnet spinning in the coil anymore. Anyway, let's assume that the battery is totally drained. This means 1.07 hours of light maximum with a 5 watts bulb out of this little battery. So I did this charge, the charged 12 volt battery, for 3,928 seconds, which in minutes is 65 minutes. So that's pretty much what the little 9 volt battery should be able to give us in light output if it would be totally drained. But again, it's not totally drained. It's probably well, I don't know, want to say it's half full, but it's not drained, so there's definitely a power plus 2. It's amazing as charging with one battery, using one battery to charge 2. We are actually still discharging the second battery, are at 11.95, 1560 seconds. So I want to show you one final thing, that you see that the battery I've been using is not totally empty. That's the battery I just did use here, and it's not capable of powering this anymore. No, can't get it to work right now. But anyway, battery is not totally empty. Let's see what the voltage on the battery is. I mean, you can see it's not totally empty because the light is still on. It's dim, but it's still on, so there must be some power left. Let's see. Got the multimeter on DC. Put it on volts. And just check the battery. 7.8. So there you get the idea. Even there must have been a power gain. So all the haters, don't hate me. But that's all I can do for now. I know this video was quite, well, I don't know, it wasn't really straightforward, but you know, it was just some information which I had to get out immediately, and I didn't want to really prepare too much for it. Actually, I couldn't prepare too much because I'm still using the circuit to discharge something, so I couldn't show you how the original setup originally was. You just have to take my word that the charging was working the way I told you. So we are still discharging, and let's see, the first battery lasted for 1553 seconds. The second battery is lasting for 1600 seconds. So we are actually drawing out of the second battery more than out of the first, but let's just once again say we got 3000 seconds out of it, which by now is already way more. 3000, divide this once again by 60, this means 50 minutes out of light and still counting, while it withdrew only 17 minutes out of light out of the battery we used for charging. I mean, wow. Let's just see, 50 divided by 17, oops, gives us 2.9. So we got the, if I'm not totally wrong here, because I'm kind of new in this field, we got a COP of 3 here, and we are not taking into account that there's a light illuminated on Richard's circuit while it's working. I'm trying to make another video to show you the circuit in operation at some point, but again, still, since I cannot explain you how to rebuild it at this point, I guess you just have to take my word for it. And maybe somebody's on YouTube who knows what's happening here in the circuit, because according to Richard, it's not his development. He just did something he's seen somewhere else, or maybe it's partially his development, where nobody has built the very same circuit before, but he adapted something. I don't really know, but to me it's not really making a difference. We just need to get this free energy deal out of here, and yes, it needs to be a larger amount than what I have on the table right here, but every long journey has to start with the first step, and I'm sure, well sure, that this is the very first step here. COP 2.9, and it's still counting. I wish it would turn off. Actually, I hope it won't turn off, but see, we are close. 1192, can't take too low, but we are at 1830. So let's do the math a final time. 1553 plus 1850, 3400 divided by 60, 56.71 minutes divided by the 17 minutes we did take out of the battery which was used to power Richter's circuit. We got a COP so far of 3.3. Damn it! Okay, again I hope you excuse that this video did not have the very best structure, but I just want to get the information out. And we go from here. Thank you for watching this video. Okay, one quick update. I'm charging the 2 empty batteries right now on the traditional way with a regular charger. And while they are charging, I got 12.5 volts coming out of the charger roughly right now. Just did hook up Richter's circuit because I want to show you how it sounds if it's running. And then let's just switch it on and listen. You actually can see the vibrations, I guess. That's a little round magnet turning. Maybe I can show you something else. No, I thought you can hear different. Yeah, you kind of can. But anyhow, this is what's happening if the circuit's running. Oh, once again. Ah, see, now it won't start. That's what I meant. You have to align this ball in there, the magnet, so it's got the right polarity, north, south, or something. There it goes. Just to show you that it's really coming from the battery here. Take off the negative. That's it. Okay. So, batteries are charging. It shows they are empty. Or it shows they are low, it can't show they are empty. But it's the ones I've been playing with. And just as a quick update, I'm still draining power from the last battery, which has been charged with Richter's circuit, where we just did the calculations. We are at 2,210 seconds. That's quite amazing that it's lasting that much longer than the first battery, because they've been charged in parallel. But oh, they're just turned off after 2,225. See, it's still moving, but it's not, the counter's not increasing anymore. $11.9. And it won't come on again right now on its own. Not at this low voltage. So, interested in doing the final math? We got 2,225 on the second battery. 2225 plus the 1553 is 3,778 divided by 60 gives us 62.9666 and so on minutes. Now I'm dividing this by the 17 minutes I took out of the battery, which was used for charging. So let's divide it by 17 and we got a COP of 3.7. Isn't this amazing? And again, you've seen it while this circuit is running. The light bulb is on, and actually there's a little LED in here which also is on. Now I know on YouTube you find plenty of other circuits which are showing you much more power gain and much more interesting things than this little amount of power coming out of the batteries. They are producing, that they say, kilowatts of power, but actually I've never seen it in person, and nobody gave me a detailed plan to reproduce it, so I don't know what to make of it. I believe it's working, but I cannot reproduce it. So right now you got the same. You can watch my video and believe it that I'm telling you the truth, but you cannot reproduce it at the time because I don't have the drawings or the plans of Ritter's circuit. We'll see if we can make this happen at some point. I'm actually not messing around with this circuit too much anymore, and I don't think I'm going to draw a circuit because that's not really my profession and take me quite a long time. I need to play around with something else, but maybe Richard or somebody else will come up who already did do the drawings, because I'm not the only one again who's having one of those circuits to play around with, and the odds are good that somebody else actually did draw a circuit, and maybe we can put a link under the YouTube video if we find it. Thank you for watching.